all the electrostatics question in the KCET 2024 question paper. So let's start. Our first question is, a body has a charge of minus 3.2 mu coulomb. The number of excess electron it has. So we know that all charge exists in the integral multiple of a charge on an electron. So this charge is also an integral multiple of a charge of electron. So minus 3.2 mu coulomb means 10 to the power minus 6 coulombs, and this will be equals to number of charge. That's what we are supposed to find, number of excess charge, number of excess electrons. So, and charge on an electron is minus 1.6 into 10 to the power minus 19 coulombs. Correct? So 1.6 ones are, and this is 2s are. This negative signs will cancel out, and this 10 to the power minus 19 will come on the other side. It will become 10 to the power plus 19. So n will be equals to 2 into 10 to the power 19 minus 6 will be 10 to the power 13. So our correct answer will be option C. Let's see the next question. A point charge A of plus 10 mu coulomb and another point charge B of plus 20 mu coulomb are kept 1 meter apart in a free space. So we have two charges, 10 mu coulombs positive charge and plus 20 mu coulombs positive charge, and they are at a distance of 1 meter. So they will apply force on each other, correct? Now the electrostatic force on A due to B is F1. So this is our A, this is our B. Force on A due to B will be in this direction, and this is named as F1 vector. And force on B due to A will be again repulsion force. It will be F2 vector. Now we know that electrostatic force are equal and opposite in nature, means F1 and F2, the amount will be equal. F1, magnitude of F1 is equals to magnitude of F2, and they are opposite in direction, means F1 vector is equals to minus times F2 vector. Any option can we see here? Option B is the correct answer. Next, a uniform electric field E is equals to 3 into 10 to the power 5 Newton Coulomb inverse is acting along a positive y-axis. So electric field is along positive y-axis like this. Okay, let's suppose this is our x-axis and this is our y-axis. Okay, and this is our z-axis. Let's make a electric flux through a rectangle of an area 10 centimeter into 30 centimeter whose plane is parallel to xz plane, means this is x and this is z plane, and we have a rectangle in this plane, x and z plane. So it will be something like this in this plane, correct? And area will be 10 into 30. Now we know that they are asking electric flux. Electric flux is electric field into area and electric field vector dot area vector. So see, area vector always perpendicular to the surface and electric field vector also in the same direction. So angle between them is 0, means cos 0 will be equals to 1. So this will be simply equals to magnitude of electric field into magnitude of A into cos 0 degree, which is equals to 1. So magnitude of E is equals to 3 into 10 to the power 5, and area is equals to 10 centimeter into 30 centimeter. Let's convert this into meters. So this will be divided by 100, 1, 2, 1, 2. Correct? So it is 3 upon 100. So area is equals to 3 divided by 100. So 2 zeros will cancel out here and it will become 3. So 3 3s are 9 into 10 to the power 3 is our correct answer for electric flux. So option B is the correct option. Now let's see another question. A total electric flux through a closed spherical surface of radius r. So this is a closed spherical surface of radius r enclosing a electric dipole of a dipole moment. So there is a dipole. Dipole is formed due to a positive charge and negative charge of equal amount. So there is a dipole inside, correct? A dipole moment of and distance between them is, so this is two charges, distance between them is a 2a, correct? So there is a dipole inside this spherical surface. Now what will be the total electric flux? Now we know that through Gauss law, total flux on this surface is equals to Q in divided by epsilon. What is Q in? The total charge inside the surface. What is the total charge inside the surface? Plus Q minus Q. Net charge is 0. So electric flux will be equals to 0. So any option? Option A is the correct option. Let's see. Next question. Under electrostatic conditions of a charged conductor, which among the following statement is true? So let's see all statements one by one. Statement A is electric field on the surface of a charged conductor is sigma upon 2 epsilon naught, where sigma is the surface charge density. So without knowing the orientation or the dimensions of the surface, we can't actually judge the electric field on the surface, correct? So A option, we can't tell it is correct or not correct. So basically we can't judge. Now let's see the next option. The electric potential inside a charged conductor is always 0. Electric potential, if it is a charged conductor, for a charged conductor, all the charge will always be on the surface, correct? So all charge is on the surface. Now electric field inside a conductor will be 0. Why? See, electric field will be 0 if you will take any Gaussian surface. Let's suppose this is a Gaussian surface. Charge inside this Gaussian surface will be 0. Flux 0 means electric field 0 inside the surface. But potential is not 0. Potential, if you will calculate at this point, let's suppose this point, it will add. See, potential is not a vector quantity. So through this charge it will add, through this charge it will add, through this charge it will add. So from all the charges it will add up and it will give us some value. So it will never be 0. It can be constant. It may be constant, but it will not be 0. Now next question. Any excess charge resides on the surface of the conductor. Just now I said if any conductor is charged conductor, all the charge will be on the surface. The reason behind this, we know that conductor is something which has free electrons. So if there are free electrons inside the conductor, means they are free to move inside the conductor. So what will happen? There will be so many free electrons and they will start repelling each other. So if 2 electrons are here inside the surface, they are close, they will try to go apart. So maximum distance that they can go is opposite ends, means maximum they can go from each other. So as far they can go from each other is on the surface. They can't jump out of the surface, right? So they will try to be at the maximum distance possible. That's why all the charge will come on the surface. They will not remain inside the surface, because if they are inside the surface, there will be so much repulsion. So this is our correct answer. Let's see option D as well. The net electric field is tangential to the surface of the conductor. No, electric field, if you have studied the properties of electric field line, it is always perpendicular to the surface. It always goes perpendicular to the surface, not tangential to the surface. So option D is also incorrect option. So only correct option is option C. So now let's see next question. A cube of side 1 centimeter contains 100 molecules, each having a induced dipole moment of 0.2 into 10 to the power 6 coulomb meter. In an external electric field of 4 Newton coulomb inverse, the electric susceptibility of the material is. So we know that net dipole moment means this N is number of molecules per unit volume. N is number of molecules per unit volume, and N into P will be equals to susceptibility into electric field. This is electric susceptibility. So formula for electric susceptibility will become N into P by E. Now what is this N? N is equals to 100 per unit volume, but volume we need in meters. We have a centimeter cube. So this 100 molecule is this 100 is 100 molecules per centimeter cube. Now we'll have to convert this into meter cube. So this will be equals to 100 into 10 to the power 6 molecules per meter cube. Now this N we can use there. So N is equals to 100 into 10 to the power 6. 100 into 10 to the power 6. Dipole moment is 0.2 into 10. This is 10 to the power minus 6 if I remember. So there is a mistake in this question. It is 10 to the power minus 6 actually. So 0.2 into 10 to the power minus 6 divided by 4. So if you will see, this plus 6 and minus 6 will cancel out. This is 2 upon 10. This is 2 upon 10. 2 ones are 2 twos are 1 0 and 1 0 will cancel out. So 10 by 2 will be equals to 5. Any option? 5. Option B is the correct option. Now let's see the next question. A capacitor of capacitance 5 mu farad. So we have capacitance 5 mu farad is charged by a battery of EMF 10 volts. So it has been charged by a battery of 10 volt. At an instant of time, the potential difference across the capacitance is 4 volts, and the time rate of change of potential difference across the capacitance is 0.6 volt per second. So when potential across this capacitance is, when potential across capacitance is 4 volts, at that time change in potential, see, time rate change of potential across the capacitance is dV by dt is given as 0.6. Now then the time rate at which the energy is stored in the capacitor at the instant is. So we know that energy stored formula. Energy stored in a capacitor is in the form of potential energy. That potential energy is equals to half CV square. Now we need time rate of this potential energy. So we will differentiate this equation. What we will get? du by dt is equals to half, C is constant, differentiation of V square will be equals to 2V, and differentiation of V with respect to time. Correct? Now we are supposed to find this. We are supposed to find this when V is equals to 4 volts. So du by dt is equals to this 2 and 2 will cancel out. C is equals to 5 mu farad, means 5 into 10 to the power minus 6 into when V is equals to 4 volts. So V is equals to 4. At that time dV by dt is equals to 0.6. So into 0.6. Correct? So this will be equals to, see, this is combined becomes 20 into 10 to the power minus 6 into 6 divided by 10. So this will become 10 to the power minus this 0 and 0 will cancel out, and 6 twos are 12. So it is 12 into 10 to the power minus 6. 12 into 10 to the power minus 6, and the minus 6 can be written as mu. So it is 12 mu watts. So du by dt is equals to 12 mu watt. Any option can you see here? Option A is the correct option. So this is all for today. I will be back with another video on current electricity. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.